The universe contains structures that should not exist, not because they are fictional, not because they break reality completely, but because the deeper astronomers look into space, the more they discover objects that seem to appear too early, grow too large, or survive under conditions that modern physics still struggles to explain. For a long time, the universe appeared orderly. Stars formed, galaxies rotated, planets orbited quietly around suns. Everything seemed governed by stable rules. But modern cosmology slowly revealed something unsettling. The rules humans understand may only describe part of reality, because hidden among ordinary stars and galaxies are structures so strange that scientists still debate how they could exist at all. Some of the strangest may have appeared near the beginning of time itself. Shortly after the Big Bang, the universe was extremely simple. Space contained mostly hydrogen and helium drifting through expanding darkness. There were no planets, no galaxies, no heavy elements, only enormous clouds of matter slowly gathering together under gravity. Eventually, the first stars began to form. At least, that is the traditional picture. But some physicists believe another kind of object may have existed before ordinary stars fully dominated the universe. Something stranger, something powered not by fusion, but by invisible matter itself. These theoretical objects are known as dark stars. Dark stars are connected to one of the largest mysteries in science: dark matter. Dark matter cannot be seen directly. It does not emit light or reflect it. But galaxies behave as though enormous amounts of invisible mass surround them. Without dark matter, galaxies would likely fly apart from their own rotation. Most of the universe may already be hidden from human observation. And in the early universe, dark matter may have shaped the first cosmic structures in unusual ways. The idea behind dark stars is surprisingly calm and simple. As gas collapsed under gravity, dark matter may have collected inside those same regions. If certain dark matter particles interacted with each other, they could release energy. Instead of ordinary fusion igniting first, this invisible energy might have heated the growing star from within. A star powered by something humans still do not understand. Some models suggest dark stars could have become enormous, far larger than ordinary stars, millions of times more massive than the sun, huge glowing structures drifting through the young universe long before galaxies fully formed. No telescope has confirmed one directly yet, but the mathematics allows them. And that alone changes something important about how humans see the cosmos. Because reality appears capable of producing structures stranger than expected, the deeper astronomy goes, the less ordinary the universe becomes. This pattern appears again and again. As scientists studied ancient galaxies, they discovered another mystery. Some galaxies formed surprisingly early after the Big Bang. According to standard models, there should not have been enough time for matter to organize into such large and developed systems. Yet distant observations revealed galaxies already shining in the young universe. Large, bright, unexpectedly mature. The James Webb Space Telescope intensified these questions even further. Some of the earliest galaxies appear more massive and organized than many cosmologists predicted. This does not mean the Big Bang theory is wrong, but it may mean the early universe behaved differently than humans expected. Perhaps matter gathered faster. Perhaps hidden physics influenced early structure formation. Or perhaps reality itself is more complicated beneath the surface equations. And this idea appears everywhere in cosmology. The universe keeps refusing to remain simple. Even empty space behaves strangely. Quantum physics suggests that the vacuum is never truly empty. Tiny fluctuations constantly appear throughout space. Particles emerge briefly, then vanish again. Beneath apparent stillness, reality is filled with hidden activity. The universe is not silent underneath. It only appears silent from far away. And perhaps this is why modern astronomy feels increasingly mysterious. Every discovery uncovers deeper layers beneath older explanations. Dark matter remains invisible. Dark energy remains unexplained. Gravity itself may behave differently under extreme conditions. The foundations of cosmology are still incomplete. And sometimes the universe reveals those missing pieces indirectly. Galaxies rotate too quickly. Stars move as though invisible mass surrounds them. Ancient structures appear earlier than expected. Reality keeps leaving clues that something larger may still be hidden beneath observable physics. Even the scale of the cosmos feels unnatural. There are stars so large they would swallow the orbit of Jupiter, nebulae stretching across hundreds of light years. galaxies colliding slowly over billions of years, and black holes containing masses billions of times greater than the Sun. The universe does not seem designed around human intuition. In fact, human intuition may be one of the worst tools for understanding cosmic reality. The brain evolved to survive on Earth, to recognize movement, predict danger, understand local environments, not to comprehend curved space-time or invisible matter shaping galaxies. And yet humans continue searching, building larger telescopes, detecting older light, looking deeper into cosmic history, trying to understand why reality behaves the way it does. But every answer seems to create another question behind it. Why did the universe begin with conditions capable of forming structure at all? Why do physical laws allow complexity? Why does invisible matter dominate galaxies? Why do some cosmic objects appear impossible under current models? Modern cosmology has explained many things, but it has also revealed how much remains unknown. Perhaps future physics will eventually explain dark stars completely. Perhaps they never existed. But even the possibility changes the emotional atmosphere of the universe, because it means reality may contain forms of matter and energy humans have barely begun to understand. The night sky appears calm from Earth, but hidden inside that darkness are structures older than planets, forces still invisible to science, and objects that quietly challenge humanity's understanding of existence itself. And stars are only the beginning, because scattered throughout the galaxy are worlds even stranger than impossible suns. But stars are only the first example of impossible structures. Not every planet belongs to a star. For most of human history, planets were imagined as stable worlds moving in quiet circles around suns. Earth orbited the sun. The other planets did the same. It seemed natural to assume this was simply how planetary systems worked everywhere in the universe. But the galaxy contains worlds that drift completely alone. No sunlight, no sunrise, no solar system surrounding them. Only darkness stretching endlessly in every direction. These are rogue planets, worlds that travel through interstellar space without orbiting any star at all. Astronomers once believed they would be rare, strange exceptions created by unusual cosmic accidents. But modern observations suggest something far more surprising. There may be billions of rogue planets inside the Milky Way alone, possibly more planets than stars. Some likely formed around ordinary stars before being thrown outward by violent gravitational interactions. Young planetary systems are unstable places. Giant planets pull on smaller worlds. Orbits shift slowly over millions of years. Sometimes entire planets are ejected completely, disappearing into deep space forever. A planet can simply be removed from its sun, and once it leaves, it enters a universe almost completely dark. Imagine standing on such a world. No bright star warming the sky, no sunrise waiting beyond the horizon, only distant stars scattered faintly across endless black space. A frozen planet drifting silently between galaxies and nebulae for billions of years. And yet, even these worlds may not be entirely lifeless. Some scientists believe rogue planets could retain underground oceans beneath thick layers of ice. Internal heat from radioactive decay or gravitational pressure might keep liquid water hidden deep below the surface. In theory, life could survive there, not under sunlight, but beneath kilometers of frozen darkness. Entire ecosystems isolated from every star in the universe. This possibility changes something important about how humans think about life itself. Perhaps stars are not always necessary. Perhaps the universe creates habitable environments in stranger ways than expected. And rogue planets are only one example, because some worlds are strange not because of where they travel, but because of what they are made of. Astronomers have discovered planets so different from Earth that they almost seem fictional. Some may contain oceans of magma stretching across their surfaces endlessly. Others may experience constant storms of vaporized metal. And a few may contain interiors rich in carbon under immense pressure, creating structures unlike anything found naturally on Earth. These are sometimes called carbon planets, worlds where carbon chemistry dominates instead of oxygen-rich geology. Under the right conditions, enormous regions of crystallized carbon may form deep inside them. In simple terms, parts of these planets could contain diamond-like structures on planetary scales, not small gemstones, entire layers of compressed carbon beneath alien skies. One famous example often discussed is 55 Cancri e, a planet orbiting a distant star roughly twice Earth's size. Early studies suggested it might contain large amounts of carbon-rich material, though later research complicated that interpretation. Still, the possibility remains scientifically fascinating because it shows how different planetary chemistry can become under changing cosmic conditions. Humans naturally imagine Earth-like worlds because Earth is the only known example of life-bearing reality. But the universe does not appear interested in repeating Earth exactly. It experiments constantly. There are planets where a year lasts only hours, planets orbiting dead stars, planets stretched by gravity into distorted shapes, worlds covered entirely by oceans thousands of kilometers deep, gas giants larger than Jupiter orbiting so close to their stars that their atmospheres evaporate into space. The more astronomers search, the more unusual planets they discover, and many of them should barely exist according to older planetary formation models. Some gas giants orbit impossibly close to their stars. These are called hot Jupiters. According to traditional theories, giant planets should form far from stellar heat, where icy material can accumulate. Yet many orbit extremely close to their suns. Something moved them inward. Planetary systems may be far more chaotic than humans once believed. Gravity reshapes everything slowly across cosmic time. Entire worlds migrate through space. Orbits collapse. Planets collide. Solar systems reorganize themselves over billions of years. The calm night sky hides enormous instability underneath. And some planets exist in environments so extreme that ordinary chemistry begins behaving differently. There may be worlds where methane falls as rain, worlds with atmospheres thicker than oceans, planets where temperatures remain hot enough to melt rock permanently. Even the concept of planet becomes difficult to define cleanly once enough strange examples are discovered. Because nature rarely respects human categories perfectly, reality forms continuous gradients rather than neat definitions. This becomes especially clear when astronomers observe brown dwarfs. Brown dwarfs exist between planets and stars, too massive to behave like ordinary planets, yet not massive enough to sustain full hydrogen fusion like true stars. Failed stars, or oversized planets, depending on perspective. Some glow faintly with residual heat for billions of years. Others contain violent atmospheric storms larger than entire solar systems. And they remind scientists that the boundary between different cosmic objects is often unclear. The universe does not divide itself neatly. Human language does. Meanwhile, somewhere in deep space, rogue planets continue drifting invisibly through darkness. Some may carry frozen oceans. Some may have moons. Some may wander the galaxy for trillions of years without ever approaching another star closely again. Lonely worlds crossing interstellar space silently. And perhaps this is one of the strangest emotional realities in astronomy. The cosmos contains enormous numbers of places humans will never see directly. Worlds without sunlight. Planets unlike Earth in every possible way. Structures formed under conditions impossible to recreate naturally on Earth. The universe is not merely larger than expected. It is more creative. And every new telescope seems to reveal another reminder that reality still contains possibilities humanity never imagined before observing them. But not all strange objects remain in planetary form. Some stars do not end quietly. For billions of years, gravity and fusion remain balanced inside an ordinary star. The outward pressure from nuclear reactions pushes against the inward force of gravity. A stable structure forms. Light escapes into space. Planets orbit nearby. The star lives calmly for immense stretches of time. But eventually, the fuel begins to disappear. And when fusion slows, gravity starts winning. For smaller stars like the Sun, the ending is relatively gentle. The outer layers drift away slowly, leaving behind a dense remnant called a white dwarf. But massive stars experience something far more violent. Their cores collapse in seconds. Temperatures rise beyond comprehension, and the star explodes outward in a supernova bright enough to briefly outshine entire galaxies. What remains afterward can become one of the strangest structures in the universe. A neutron star. Neutron stars are difficult to imagine properly because human intuition has no equivalent for their density. A neutron star may contain more mass than the Sun compressed into a sphere only about 20 kilometers wide. Gravity crushes matter so intensely that electrons and protons merge together, forming neutrons packed almost directly against one another. Most empty space inside atoms disappears. Matter itself changes state. A simple analogy is often used by astronomers. A teaspoon of neutron star material would weigh billions of tons on Earth. But even that comparison barely captures the reality. Neutron stars are not simply heavy objects. They are environments where ordinary physics begins reaching its limits. The surface gravity becomes extreme. Magnetic fields grow unimaginably powerful. Some neutron stars rotate hundreds of times every second, emitting beams of radiation through space like enormous cosmic lighthouses. These are pulsars. When pulsars were first discovered in 1967, their signals seemed so strangely regular that scientists briefly considered the possibility of artificial origin. The pulses repeated with astonishing precision. Eventually, astronomers realized they were observing rotating neutron stars, dead stars still sending rhythmic signals across the galaxy. Even in death, some stars remain active for millions of years. And the deeper scientists studied neutron stars, the stranger they became. Inside them, matter may exist in forms impossible to recreate naturally on Earth. Some theories suggest the cores of neutron stars contain exotic states of matter unlike anything humans fully understand. Possibly superfluids, possibly quark matter, possibly structures physics has not yet fully described. These stars are like laboratories for extreme reality, places where the universe tests the limits of matter itself. And yet, even neutron stars are not the strangest remnants gravity can create. Because if a collapsing star contains enough mass, gravity overwhelms everything completely. No known force stops the collapse. The star contracts inward endlessly, and eventually, a black hole forms. Black holes are regions where gravity becomes so intense that nothing can escape once it crosses a boundary called the event horizon. Not matter, not radiation, not even light itself. For a long time, black holes seemed almost mathematical rather than physical. Strange consequences of Einstein's equations that felt too extreme to truly exist. But over the last century, evidence accumulated steadily. Stars orbiting invisible objects, X-rays from superheated materials spiraling inward, gravitational waves from black hole collisions, and eventually, the first direct image of a black hole's shadow itself. Humanity discovered that these impossible objects are real, and they may exist everywhere. Some black holes form from dying stars. Others are vastly larger. At the center of most galaxies, including the Milky Way, lies a supermassive black hole containing millions or billions of solar masses. These enormous structures shape entire galaxies through gravity. But some of them create a major cosmological problem, because astronomers discovered supermassive black holes existing extremely early in the universe. Too early. According to ordinary growth models, black holes should require long periods of time to become so massive. They grow by absorbing matter and merging with other black holes. But observations revealed gigantic black holes already existing when the universe was still very young. Some formed less than 1 billion years after the Big Bang, and scientists still debate how this happened. Perhaps early stars were much larger than expected. Perhaps black holes formed directly from enormous collapsing gas clouds. Perhaps unknown physics accelerated their growth. No complete answer exists yet. And this mystery matters because it suggests current cosmological models may still be incomplete. The universe appears capable of building enormous structures faster than expected. Again and again, astronomy reveals objects that seem to challenge timing itself. Galaxies too mature, black holes too massive, structures appearing before theory predicts they should. Reality keeps moving slightly ahead of explanation. Meanwhile, black holes themselves continue creating deeper questions. What happens inside them? Modern physics cannot fully answer. General relativity predicts collapse toward a singularity, a region where density becomes effectively infinite and the known laws of physics break apart mathematically. But many physicists believe singularities signal incomplete theory rather than physical reality. Quantum mechanics likely becomes important under such extreme conditions. Yet no complete theory successfully unites gravity and quantum physics. Black holes sit directly at that boundary. They are places where humanity's two greatest scientific frameworks stop fitting together cleanly. And because of this, black holes became central to some of the deepest mysteries in science. Stephen Hawking discovered that black holes are not completely black forever. Through quantum effects near the event horizon, they slowly lose energy over immense timescales. Black holes can eventually evaporate. This discovery created another problem known as the information paradox. If black holes disappear, what happens to the information carried by the matter that fell inside them? Quantum physics suggests information cannot truly vanish, but black holes seemed capable of destroying it. This paradox has driven decades of theoretical research, and even now, physicists still debate the full solution. Some believe information remains encoded on the event horizon itself. Others propose deeper holographic principles governing space-time. Again, black holes reveal missing pieces inside modern physics, not because they are fictional, but because they force reality into its most extreme conditions. And perhaps that is why these objects feel so mysterious emotionally. They are not merely distant astronomical structures. They are boundaries, places where human understanding begins fading into uncertainty. Neutron stars compress matter beyond intuition. Black holes distort space-time itself. And somewhere inside these extreme remnants may exist clues about the true structure of reality. But even these strange objects are not the largest mysteries in the cosmos. And yet, even these are not the largest mysteries. Most humans grow up imagining stars alone, a single sun in the sky, one source of light around which planets quietly orbit. But throughout the galaxy, many stars exist in pairs. Some exist in groups of 3 or more. Entire solar systems move through space beneath multiple suns. Binary star systems are extremely common in the universe. In some regions of the galaxy, they may even outnumber single star systems like our own. 2 stars orbit each other slowly over millions or billions of years, locked together by gravity. And around some of these stars, planets exist as well, worlds with 2 suns in their skies. Not science fiction, real planetary systems. Astronomers have discovered several examples already. One of the most famous is Kepler 16b, a planet orbiting 2 stars simultaneously. Its sunsets would look completely different from anything seen on Earth. 2 moving stars, 2 shifting shadows, a sky governed by more complicated rhythms. At first, scientists were unsure whether stable planetary orbits could even survive inside binary systems. The gravity becomes more complex. Orbits shift constantly. Conditions appear chaotic, and yet planets still form there. The universe repeatedly demonstrates that stability can emerge from environments humans once considered impossible. Some multi-star systems contain worlds where daylight may never fully disappear. Others may experience long periods of darkness followed by twin sunrises crossing the horizon together. The galaxy contains skies stranger than human imagination expected, and these systems are only small pieces of something vastly larger. Because stars themselves gather into galaxies, galaxies gather into clusters, and clusters connect across the universe through structures so enormous that the human brain struggles to visualize them properly. This structure is known as the cosmic web. On the largest scales ever observed, galaxies are not distributed randomly through space. Instead, they form gigantic filaments stretching across hundreds of millions of light years. Immense rivers of galaxies crossing the cosmos. Between these filaments lie enormous voids where very little matter exists at all. The observable universe resembles a vast network, almost organic in appearance, not because it is alive, but because gravity slowly shaped matter into interconnected structures over billions of years. Dark matter likely played a major role in this process. Invisible gravitational scaffolding may have guided ordinary matter into filaments and clusters during the early universe. Galaxies formed along hidden structures humans still cannot directly observe. Even the architecture of the cosmos may depend on invisible matter, and the scale of these formations is difficult to emotionally process. Light itself travels nearly 300,000 kilometers every second. Yet, even moving at that speed, crossing a single galaxy can require over 100,000 years. The cosmic web extends across distances millions of times larger still. Human civilization exists inside only a tiny region of one galaxy connected to a filament inside an unimaginably larger cosmic structure. The universe is not only large, it is layered. Planets orbit stars. Stars gather into galaxies. Galaxies form clusters. Clusters connect into filaments. And those filaments stretch across the observable universe itself. Every scale reveals larger patterns hidden above it. But despite all this structure, something deeply mysterious still moves through space. Signals. Brief flashes of radio energy arriving from distant galaxies, some lasting only milliseconds, yet carrying enormous amounts of power. These are called fast radio bursts, and scientists still do not fully understand what creates them. The first fast radio burst was discovered accidentally in 2007 while astronomers analyzed older telescope data. At first, many researchers thought it might simply be interference or error, but more signals appeared, again and again. Tiny flashes crossing the cosmos. Some release more energy in milliseconds than the sun emits in days. Most arrive only once, a sudden burst, then silence forever. But a few repeat unpredictably, returning months or years later from the same region of space. Astronomers have traced some fast radio bursts back to distant galaxies billions of light years away. Whatever produces them must survive extreme conditions and release extraordinary energy. Several explanations exist. Highly magnetized neutron stars called magnetars may generate some bursts during violent magnetic activity. Other theories involve compact object collisions or exotic plasma interactions, but no single explanation fully accounts for every observed signal. And this uncertainty gives fast radio bursts a strange emotional atmosphere. The universe appears to flash briefly with unexplained energy from distant regions humans cannot directly explore. Tiny cosmic messages without clear origin, not artificial, not supernatural, simply unknown. And perhaps this is one of the most important feelings modern astronomy creates. Not fear, not certainty, but humility, because every new telescope reveals how incomplete human understanding still is. For centuries, people believed the stars were fixed lights attached to a perfect celestial sphere. Now humans study black holes, invisible matter, exploding stars, rogue planets, and galaxy-spanning structures woven through the universe itself. And still, enormous mysteries remain unresolved. What exactly is dark matter? Why does dark energy accelerate expansion? How did the first structures form so quickly? What creates fast radio bursts? What physics still remains hidden beneath observable reality? The universe keeps expanding scientifically, but also emotionally. Every discovery increases scale. Every answer uncovers deeper uncertainty. And perhaps that is why space feels so calming and mysterious at the same time. The cosmos does not seem built around human expectations. It simply exists according to laws humanity is still slowly uncovering. Stars orbit other stars. Galaxies form colossal filaments. Invisible matter shapes cosmic structure. Unknown signals travel across billions of light years before reaching Earth. Reality is already stranger than older generations imagined possible. And perhaps the greatest mystery is not hidden inside distant galaxies or black holes. Perhaps it exists inside the missing pieces of physics themselves. But the biggest mystery is not what we see, but what we don't understand. The more humanity studies the universe, the clearer one fact becomes. Most of reality is still unknown. Modern cosmology appears powerful from the outside. Telescopes can observe ancient galaxies billions of light years away. Spacecraft cross the solar system. Scientists detect gravitational waves from colliding black holes. Human knowledge has expanded enormously. And yet, beneath all of these discoveries, physics still contains enormous gaps. Astronomers can calculate the motion of galaxies with extraordinary precision, but much of the mass controlling those galaxies remains invisible. This invisible component is called dark matter. No one has ever seen dark matter directly. It does not glow. It does not reflect light. It moves silently through the universe, interacting mainly through gravity. Without it, galaxies should not behave the way they do. Stars near the edges of galaxies orbit too quickly. Large cosmic structures formed faster than expected. Something unseen appears to hold enormous regions of the universe together. And according to current estimates, ordinary matter, stars, planets, gas, dust, and everything humans can physically see may represent only a small fraction of cosmic existence. Most matter may already be hidden, but the mystery becomes even stranger. Because dark matter is not the largest unknown in cosmology. That role belongs to dark energy. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not simply drifting apart. Over enormous distances, space itself expands faster over time. Something appears to be pushing the cosmos outward. This unknown effect was named dark energy. Today, scientists estimate that dark energy may make up most of the universe. And yet humanity still does not understand what it is. The largest component of existence remains unexplained. This creates a strange emotional contradiction in modern science. Humans know more about the universe than any previous civilization in history. But at the same time, most of reality may still be fundamentally mysterious. The visible cosmos could be only the surface layer of something much deeper. And perhaps this is why cosmology feels increasingly philosophical the further it advances. Because eventually, science reaches the edges of observation itself. There are limits humans cannot easily cross. The observable universe contains only the regions whose light has had enough time to reach Earth since the Big Bang. Beyond that boundary may exist vastly more cosmos forever unreachable. There could be structures larger than anything humans have observed, different regions of space-time, possibly even entirely different physical conditions. But no information from beyond the observable horizon can currently reach humanity. There are parts of reality permanently hidden by cosmic expansion. The universe contains natural limits to knowledge. And even inside the observable cosmos, uncertainty remains everywhere. Physicists still cannot fully combine quantum mechanics with gravity into a single consistent framework. Black holes continue generating paradoxes. The earliest moments after the Big Bang remain unclear. The deeper science explores, the more the universe seems layered with unanswered questions. Some theories suggest space-time itself may not be fundamental. Others propose extra dimensions hidden beyond ordinary perception. Quantum physics hints that reality behaves probabilistically beneath the surface of everyday experience. Even empty space is filled with invisible fluctuations. The universe appears calm from human scale, but underneath, reality may be unimaginably complex. And perhaps this complexity is natural. After all, humans are a very recent species living on a small planet around an ordinary star inside one galaxy among trillions. There is no reason the cosmos should immediately make sense to biological minds evolved for survival on Earth. Human intuition was never designed for cosmic scales. Yet humans continue searching anyway, building larger observatories, listening for distant signals, tracing ancient light backward through time, trying to understand how existence itself functions. And this search has already transformed humanity's view of reality completely. The Earth is no longer the center of the universe. The Sun is one star among billions. The Milky Way is one galaxy among trillions. Even visible matter may represent only a small fraction of existence. Every century, the cosmos becomes larger, stranger, more mysterious, but also more beautiful, because uncertainty does not make the universe meaningless. If anything, it makes reality feel deeper. The night sky is no longer just a collection of stars. It is a record of cosmic history. Ancient light crossing billions of years before reaching human eyes. Every distant galaxy represents another enormous structure filled with stars, planets, and unknown possibilities. And beyond all observable light, more reality may still exist silently outside human perception. Perhaps future generations will solve some of these mysteries. Perhaps dark matter will finally be detected directly. Perhaps dark energy will become understandable. Perhaps entirely new laws of physics remain waiting to be discovered. Or perhaps the universe will always contain regions beyond complete comprehension, not because science fails, but because reality itself is larger than any single explanation. And maybe that is part of what makes the cosmos feel so peaceful. The universe does not demand certainty. It simply continues existing across unimaginable scales, quietly revealing itself piece by piece. Stars form, galaxies drift, black holes grow, light crosses the darkness for billions of years. And somewhere on one small planet, conscious beings continue looking upward, slowly learning how little they truly know. The universe is not strange, we are just still learning how to see it.